Hi girls, today we're going to continue with a list of objectives. Last week we talked about types of energy and we learned how one type of energy converts into another type. And we talked about the law of conservation of energy briefly. We said that energy is neither created nor destroyed, only it transforms from one shape to another or from one place to another. We also talked about the types of kinetic energy. We have defined and mentioned the types of potential energy. Today we're going to define gravitational potential energy and its equation, and we're going to study the effect of choosing the reference level on the amount of GPE an object has. After that, we're going to study energy conversions in a separate video. Now, the other type of potential energy is called the gravitational potential energy, طاقة المخزنة الجاذبية, and we symbolize it with GPE, which is the beginning letter of each word, gravitational potential energy. And because it's an energy, it's also measured in joules. Now, gravitational potential energy is the energy stored in an object due to gravity. When you lift an object up the ground, higher and higher, you store gravitational potential energy in it. The higher you lift it upwards, the more energy you store in it. We can calculate the gravitational potential energy by using this equation. The gravitational potential energy stored in an object lifted above the ground is equal to the mass in kilograms multiplied by g, which is the gravitational field, and on Earth it is equal to 9.8 newtons per kilogram, multiplied by h, which is the height from the reference level. That makes the equation GPE equals mgh. Now be careful about the reference level. Reference level is the point or the surface you measure your heights from, and it can differ from one situation to another. So for example, I can measure the height of a light bulb from the surface of the ground. Another person can measure the height of the light bulb on the ceiling from, for example, the table as the reference level. If you change the reference level that you measure the height from, the amount of the gravitational potential energy will change as well, because as you can see, it depends on the height, which can be measured according to a reference level. And we will see an example at the end of the video. So, what does the gravitational potential energy stored in the object depends on? According to the equation mgh, you can see that the gravitational potential energy depends on two factors, or three factors, but as long as we are on Earth, it's just two factors. The first factor is the mass. You can see that bigger the mass, the more gravitational potential energy the object stores. So, the gravitational potential energy stored in a piano will be much higher than the gravitational potential energy stored in a watermelon if they are pulled at the same height. That's because the piano has a bigger mass. So if the piano falls on this person, he will definitely die because this piano holds a lot of stored energy, and this stored energy will convert it into kinetic energy. And this kinetic energy, this big amount of kinetic energy, will crush this person. While here, in the watermelon, because it has a small mass, it will have a smaller amount of energy stored in it. And this stored energy, the small amount, will turn into a small amount of kinetic energy, which will not harm this person, not as much as the first person anyways. What's the other factor that the gravitational potential energy depends on? Now you can see according to the equation, it also depends on the height you lift the object from. And as the height increases, the gravitational potential energy stored in the object increases as well. So, for example, if you were to hold a watermelon at a very small height and then drop it, nothing will happen to the watermelon because you lift it a little bit above the ground. It stored a little bit of gravitational potential energy, in which turned into a little bit of kinetic energy when you let go of it. But on the other hand, if you take this watermelon and lift it above a building and then let it go, when it hits the ground, it will be crushed. Why? Because when you lift it above the ground at a very high or like at a high heights, say, or a very big distance from the ground, this watermelon will store a lot of gravitational potential energy in it. And this massive amount of gravitational potential energy stored in the watermelon will be converted into kinetic energy, which is a massive amount of kinetic energy when it reaches the ground. Hence, because it has a lot of kinetic energy, it will hit the ground at a high speed, which will cause it to explode. So again, the height at which we lift the object affects the gravitational potential energy. The higher the object, the more energy is stored in the object. Let's see this question. A pole vaulter of a mass 52 kilograms. So given here is the mass of this pole vaulter. We're going to symbolize it with M. Jumps to a height of 6.12 meters. So that's the height, h. And you can see that the height is measured from the ground. So the ground here is the reference level. To clear a bar as shown in the figure, what is the gravitational potential energy stored in the pole vaulter at that height? So he wants you to find how much energy was stored in this person when he jumped or when he reached that height. So GPE is equal to mgh. Multiplying the mass, you can see all of the quantities are in their right units. So the mass is 52. And remember, G is a constant value of 9.8. G is always 9.8 on the ground, unless it's mentioned otherwise, which you will use the new value given to you in the exam, times the height, which is 6.12. Now using the calculator, 52 times 9.8 times 6.12 will give you 3,118.7 joules of energy, which is the first answer right here. Okay, now let's talk about the reference level اللي هو بالعربي مستوى المرجع. The amount and sign of the gravitational potential energy depends on the chosen reference level. تعتمد قيمة وإشارة الطاقة الجاذبية المخزنة في الجسم على المستوى المرجعي الذي تم اختياره. فمثلا خلينا نفترض إنه عندنا هون بطيخة موضوعة على سطح الأرض. هاي البطيخة موجودة بجانب شخص، هذا الشخص باللون الأزرق. هنا في عندي شخص باللون الأصفر يقف على شرفة أحد الشقق، وعندنا شخص باللون الزهري يقع في حفرة تحت مستوى الأرض. فنفترض إنه بدنا نوجد كمية الطاقة المخزنة الجاذبية التي تمتلكها هذه البطيخة بالنسبة إلى 3 مستويات مرجعية. فلنبتدئ في المستوى المرجعي اللي هو الأرض. خلينا نفترض إنه إحنا اخترنا المستوى المرجعي. We chose the reference level to be the surface of the ground. So we're going to measure the distances and the heights from the surface of the ground. Now this watermelon, هاي البطيخة موضوعة على المستوى المرجعي. هذه البطيخة, this watermelon, is placed on the reference level. So how far away is it from the surface of the ground? Well, because it's placed on the ground and we're measuring the heights from the ground, the height here is 0. It's not lifted, nor it's below the reference level. Hence, if the reference level is chosen to be the ground, the melon is at a height of 0 meter from the ground. And hence, if you want to calculate the gravitational potential energy, multiplying the mass of the watermelon times 9.8 times h, which is 0, will give you a gravitational potential energy of 0. But now let's imagine we're going to measure the gravitational potential energy of the same watermelon, but from a different reference level. Now we're going to choose the reference level to be the balcony. So we're going to measure the heights and depths from the balcony. So here the balcony is the reference level at which the height is 0 and the gravitational potential energy of anything placed on the balcony would be zero as well. So the gravitational potential energy stored in this person, according to this reference level, is zero as well because he's on the reference level. But how much is the gravitational potential energy of this watermelon if you chose this reference level? You can see now that the watermelon is below the reference level. You can see that is, for example, 7 meters below. So if the reference level is the balcony, the melon is 7 meters below. So it will have a negative gravitational potential energy. If you calculate it, you'll multiply the mass of the watermelon times 9.8 times h, which will be negative 7. So the gravitational potential energy of the same watermelon would be a negative value, like for example, negative 35 or negative 40 joules. Even though it's the same watermelon, just because we changed the reference level, the amount of the gravitational potential energy stored in this watermelon changed as well. But now let's choose the hole as the reference level. So we are measuring the heights from the hole. Now you can see if the reference level is the hole, the melon is 5 meters above the reference level, and hence it will have positive GPE. So if we want to calculate the gravitational potential energy of the same watermelon, you'll multiply its mass times 9.8 times h. In this case, it will be positive 5. So it will give you a positive value for GPE. So you can see that changing the reference level changes the amount of the gravitational potential energy stored in the object, even if it's the same object. So here it was 0, here it was negative, and here it was positive. Let's solve an example on that. We're going to delete everything here and solve again. Right. This question says we have an 0.5 kilogram vase, so that's the mass of the vase. And this vase is placed on a table in the following image. You can see the vase is on the desk here. Find the amount of the gravitational potential energy stored in the vase at the following Find the amount of gravitational potential energy it has according to the following reference levels. The first reference level chosen is to be the ground. So here we're measuring the heights and depths from the ground. In this case, you can see that this vase is 1.5 meters above the ground. Hence, to find the gravitational potential energy in the vase, we will multiply mg times h. Its mass is 0.5, and g is a constant value, always, دائما, 9.8, unless mentioned otherwise in the question, times h. Now, because we chose the ground as the reference level, you can see that this vase is 1.5 meters above the reference level, so it's 1.5 positive. Using the calculator, if you multiply 0.5 times 9.8 times 1.5, gives you a syntax error. 9.8 times 9.8. That gives you 7.35. Right. Now, in the second branch, you want to find the amount of the gravitational potential energy stored in the vase, but we're going to choose the desk as the surface level or the reference level. So now we're measuring the height from the desk. Now, because this vase is placed on the desk, it's not lifted above it, so it's at the height 0 from the desk. That means if you multiply mgh, it's the same as 9.84g, but because the vase is placed on the desk, it's at a 0 meters height from the desk. So that will give it as 0 joules of energy. Lastly, he wants us to find the gravitational potential energy stored in the vase if we measure our heights and depths from the ceiling. So we're measuring the heights and depths from the ceiling. Similarly, GPE equals mgh. The mass is 0.5 and g is 9.8. But for the height, you can see that the vase is 2 meters below the reference level. So below, since it's below, we're going to put negative. Remember, anything above the zero is going to be positive. Anything below the zero is going to be negative. So since it's below the reference level, it's going to have a negative value, -2. So multiplying this using the calculator, 0.5 times 9.8 times -2 will give you -9.8. So you can see that changing the reference level from which we measure the heights and the depths changes the amount of the gravitational potential energy stored in the same object.